Let's get started. Question number 1 is about an absolute equation with exponents, and we have to solve this equation. So to get rid of absolute sign, we should square both sides. So let me write the equation first and then square it. Squaring ensures that whatever we has is positive on both sides, and accordingly we can get the answers. So when I square 4, I'll get 16, and because this absolute is 100% positive now, so we can write it as a bracket only. So it will be 5 to the power x minus 1 square equal to 5 to the power x square. So let's get this one expanded, and we can use this identity to expand it. A minus b is equal to a square plus b square minus 2ab. This is a very famous identity, and that's what we will use to expand this bracket. So 16 remains 16, and we get here 5 to the power x square, which is a square, plus b square minus 2ab and equal to 5 to the power x square. So let's open the bracket by multiplying every one by 16. So it becomes 16 5 to the power x square plus 16 minus 16 times 2 is 32, and that's a 32 5 to the power x. Let me write it this way, equal to 5x square. So let's assume now 5 to the power x equal to t, so that it becomes simpler. So our equation becomes 6t square plus 16 minus 32t equal to t square. Alright, this t square and this t square can become 1 when this comes to the left side. We are left with 15t square minus 32t plus 16 equal to 0, and this becomes a quadratic equation which we can solve. You can use your calculator to find this, but I will factor 15 times 16, 240, 13, 20, 12. Okay, 15t square minus 20t minus 12t plus 16 equal to 0. If you are not comfortable with this kind of process, please, you can use your calculator straight away. It gives you solution. So we'll be left here with 3t minus 4. Okay. So two factors I get are 5t minus 4 and 3t minus 4 equal to 0. This one will give me 5t minus 4 equal to 0, t equal to 4/5. And this one will be 3t minus 4 equal to 0, t is 4/3. Alright, so t was not t, we assumed it in place of 5 to the power x, so we'll replace it now. And here also 5 to the power x equal to 4/3. And now we can let's simplify them till down there. Okay, let's apply log to get the value of x on both sides. So log here and log here as well. So whenever we want to evaluate x, x can become a coefficient of this, so it becomes x log 5 equal to log 4/5. So x will be log 4/5 over log 5. Similarly, if I use the same steps here as well, I'll get x equal to log 4/3 over log 5. And we'll simply use our calculator. We'll place this thing in our calculators and we'll get the value. Let me do that on mine. By the time I do this, I would request you to subscribe to my channel and like and share this video with your friends so that they also get benefited with you, and we increase the knowledge together. So when I use my calculator for this one, I got minus 0.139, and for this I got 0.179, and in exponents negative is acceptable. So both of them will be the solution. Let's move on to the next question, which is this. A part of question 2 is express 5 sin x minus 3 cos x in this format, and two special cases has been given to us, that r is positive more than 0 and alpha is between 0 and pi by 2, and we have to give the exact value of r and give alpha to two decimal places. Alright, so what do we do? To start, let's write what is the expression they've given. 5 cos x, sorry, it is sin x. 5 sin x minus 3 cos x, and let's expand this below it. R, it is r sin x minus alpha, which is equal to this, and we will expand it just below the expression we have. It will be r, and let's start a bracket here, sin x cos alpha minus cos x sin alpha. Okay, and since now we have two terms, we can write this r in place of outside inside. So in next step you can write this. I'm straight away writing it inside and multiplying with both. Alright, so now compare this expression with these two. We can see that sin x is here as well as here, cos x is here as well as here. So what is remaining? What is remaining in this one? In this 5 is remaining, but in this expression r cos alpha is remaining, and we will write r cos alpha equal to 5. Similarly, 3 is remaining here and r sin alpha is remaining in this one. So by comparing them, we get r sin alpha equal to 3. And whenever we have r sin alpha and r cos alpha format, divide this sin alpha by the cos alpha equation. So I divided the left side by the left side and right side by the right side. So it became this. Sin over cos, that is a specific order because r gets cancelled, and sin over cos is tan alpha, and tan alpha is 3/5. And if we want to find alpha, it will be tan inverse 3/5, which will be 0.54 radians. Why radians? Because they said our angle should be between 0 and pi by 2, and pi by 2 is radians, and that's why we give our answer in radians. So whenever they say radians, we should give answer in radian. If we give in degrees, we'll get lesser marks. Alright, the second part is to find exact value of r. For that, let's do one thing. We square this equation both sides and this equation both sides, the one we had originally. So let me write them here. So r square sin square alpha equal to 9, and r square cos square alpha equal to 5 square, 25. I could have simply put this angle into one of these equations and gotten r, but since they said that we want exact value, we wouldn't get an exact value because 0.54 is a decimal, it's a rounded off decimal, and we would not get an exact value. So we have to do this way. And why do we do this way? Look, we will add the left side with left, right with right. 25 plus 9 is 34. And in these two expressions, r square is common, that is the GCF. What is remaining, we'll write that side inside bracket. So sin square alpha over cos square alpha, which is 1. So that gives us r square equal to 34. And that was the purpose, so that we get rid of sin and cos. Square root both sides now. So r will be plus or minus 34. But since they said r is greater than 0, we will ignore negative, no negative, only positive square root 34. We got r and alpha both. Next part, what does it say? It says find the greatest and least possible values of square of the expression they gave us, right? And the expression we converted this expression into square root 34 sine x minus alpha. Okay, and because there is a square here, let's square it. Okay, so to find the greatest and least possible values, we should first know what is the greatest and least value of any y equal to sine a sine bx plus c, right? This is always the amplitude, this is the axis of the graph, and this is the 2 pi over period. Okay, since this angle just provides a period or phase shift, like alpha is providing a phase shift, so we will not even look at this because they are asking maximum, greatest and least possible value. So only amplitude and axis are the ones which cause maximum and minimum, greatest and least possible. Let me draw the graph of a simple sine graph. This is simple sine graph. The greatest value of a sine graph is 1 and the least possible value is minus 1. But if there is an amplitude written in front of x, sine x, the one I have drawn here is y equal to sine x. But if there is an a in front, the greatest value becomes a and least value becomes minus a. And in this case, we have square root 34 as the greatest value and minus square root 34 as least value, because there is no axis here, because our equation here is square root 34 sine x minus alpha plus nothing. Plus nothing means axis is the x-axis. This is the axis. So we don't have to worry about the axis. Alright, but this is the maximum and minimum for a simple sine equation. This equation is squared. Now listen very carefully. When we square a graph, the y value, because if I say y equal to this, so that means y value, which was the original this, is squared. So only y value gets affected. That's why I said there is no need to panic about the angle. So what is the square of square root 34? A complete 34. Square root 34 will be about 5 point something, say 8 or 7. But 34 will be very, very high as compared to this. So it will make the maximum value as 34. Now, minus square root 34. What is the square of minus square root 34? Is also positive 34. That means this part of the graph, because of the square, will be like this. So your graph will be only positive above x-axis, never below x-axis. And now we can tell very easily what is the greatest value. So the greatest value is 34 and least value we can see is here, x-axis, where y is 0. Whenever they say greatest and least value, we talk about y value, and they are 34 and 0 respectively. Let's move on to the next one, which is this. The curve with equation y equal to x e to the power 1 minus 2x has one stationary point. Find the coordinates of this point. So to find the stationary point, we know that at stationary point, which is the turning point, the gradient is 0. And gradient is nothing but dy over dx of the curve. So let's find the differentiation of this main equation. Dy over dx will be, because there are two parts, x and e to the power 1 minus 2x, both of them have variable. That's why we'll use product rule. In product rule, we differentiate one part and do not touch the other one, and in the second part, we do the reverse. Alright, so the differentiation of x is just 1 e to the power 1 minus 2x plus x, and the differentiation of this is itself multiplied by the differentiation of the exponent. So dy over dx becomes e to power 1 minus 2x minus 2x because of x and minus 2 multiplying e to power 1 minus 2x. This has to be equal to 0 because the gradient is horizontal. It has its value 0. Now, when there is a combination of algebraic and exponential part, we cannot easily find the 0. So for that, we have to factor the one which is not 0. That means the right hand side part here. So e to power 1 minus 2x is the GCF. We can take it common. We are left with 1 minus 2x, which is equal to 0. By rules of solving an equation, e to power 1 minus 2x has to be equal to 0, which is not possible because e is a constant. No matter what is the exponent, its value will never be 0. So this cannot be an answer, and this is the only one that will give us answer. And let me write equal to 2x. So x equal to 1 over 2. Positive half is the value of x where the stationary point occurs, but the question is find the coordinates of this point. So we know only the x coordinate. We want to find the y coordinate. We can substitute this half into the main equation, which will be x is half e to the power 1 minus 2 times half. I'm talking about this equation. Alright, so it becomes half e to the power 2 and 2 cancel. Okay, 1 and minus 1 also cancel, they become 0. E to the power 0 is 1, so half times 1 is half. So the coordinates of stationary point are half, half. Let's see what they ask in the next part. Determine whether the stationary point is a maximum or a minimum. So to determine whether a stationary point is maximum or minimum, we carry out the second derivative. So we will carry out this for the given function. So we know dy dx is this. Let me show you here. This is dy over dx, right? So let's differentiate this one. Let's write that equation here. So dy over dx is e to the power 1 minus 2x minus 2x e to the power 1 minus 2x. Alright, so the differentiation of this was done already. E to the power 1 minus 2x itself multiplied by minus 2. Okay. Now again we will use what second derivative here. So second derivative means the product rule will be used here again. So differentiation of 2x is just 2 e to the power 1 minus 2x. Then we'll keep the minus 2x same, but we'll differentiate that, which will be e to the power 1 minus 2x multiplied by minus 2 again. So let's see what it gives us. It gives us minus 2 e to the power 1 minus 2x minus 2 e to the power 1 minus 2x exactly same plus 4x e to the power 1 minus 2x. Alright, so now we'll plug in, because x was half 1 over 2, so we'll plug in that 1 by 1 in every x value, and let's see whether we get a negative value or a positive value. So minus 2 e to the power 1 minus 2 times half minus 2 e to the power 1 minus, rather I could have made minus 4 and don't write it again, plus 4 times 1 over 2 e to the power 1 minus 2 times half. I wrote this minus 4 because minus 2 and minus 2 together will be minus 4. So 2 and 2 cancel, e to the power 0, so we are left with only minus 4 here. Here this 2 and this 4 will cancel, so will be plus 2, and same thing here, it will be e to the power 0 and 1. Answer is negative 2. Negative means it's opening down, and that's why this particular point, this stationary point, is a maximum. Any graph that opens down is a maximum because this is the peak and it will have a maximum at that point. Next question is question number 4. Using substitution u equal to square root x, find the exact value of this definite integral. Okay. So first of all, let's substitute everything using the substitution they have suggested. So u is square root x, du over dx will be, first of all, square root of x can be written as 1 over 2. So it will be 1 over 2 x to the power half minus 1, which is 1 over 2 x to the power minus half. That makes it 1 over 2 square root x. Alright. So in this part of the integration, let's not write the limits right now, but substitute what we want. So you can see that there is no 2. So we can write 2 in front of this and multiply the whole thing by 2. So denominator and numerator both are multiplied by 2. That doesn't make any difference to the expression, but it shows that 1 over square root 2x dx is du. That's what we just got it. That was du. Right? So let's write du. So 1 over x. Now if u is square root x, u square will be square root x square. So u square will be x. That means this x can be written as u square plus 1. There is 2 in front. Now we have to write what is here as the limits. So when x is 3, this 3. So our substitution is u equal to square root x. So when x is 3, u will be square root 3. So that means the lower limit is not 3 anymore, it will be square root 3. When x is infinity, u will be square root of infinity, which is again infinity. Of square root of a big number, very big number will be a very big number. So that limit becomes infinity. And now it is 1 over u square plus 1 format, and this format we are already aware that it will be tan inverse u. That will be the integration of this particular format, 1 over u square plus 1. And it is from square root 3 till infinity. So let's substitute the parts of limits into this solution. 2 tan inverse infinity is plus c, right? Let me put a bracket here so that we can subtract the remaining one. Tan inverse square root 3 and plus c. Now tan inverse infinity, they're saying, if we look at the graph of tan, it looks like this. And there is an asymptote at pi over 2. At 0, it is the x-intercept. But at pi over 2, it is undefined, and that is infinity. And this infinity is positive infinity. That means the angle we are talking about is pi by 2. So we can write here 2 times pi by 2 minus, plus c rather, minus tan inverse square root 3 will be pi by 3, and plus c minus c. And 2 times pi by 2 minus pi by 3 will be pi by 6. And 2 and 6 cancel out. It will be pi over 3 or 1 over 3 pi, whatever format you want to write. This will be the solution of the given definite integral. Okay, Next one is show that the equation cot 2 theta plus cot theta is equal to 2 can be expressed as a quadratic equation in terms of tan theta. Okay, so we know that cot 2 theta is 1 over tan 2 theta. Similarly, cot theta is 1 over tan theta will be equal to 2. Now we can use the double angle identity in this one. We know that tan 2a, this is the identity, equal to 2 tan a over 1 minus tan square a. That's what we'll do, but the reciprocal, because it is 1 over, it's a reciprocal. So we'll write the reciprocal of this part. It will be 1 minus tan square theta over 2 tan theta plus 1 over tan theta equal to 2. And now we can see that both of them have tan theta, and if we multiply whole equation by tan theta, we'll get rid of them. And additionally, we can multiply by 2 tan theta, so that 2 also gets cancelled out. Alright, so let's multiply this with the first term, where the denominator will cancel out with what we are multiplying with. So we'll be left with only 1 minus tan square theta here. Now, if I multiply this with the second one, tan theta will cancel out, but 2 will still be there. So I'll be left here with plus 2. And when you multiply 2 tan theta with just 2, it becomes 4 tan theta. The denominator are not there anymore. So let's bring everything to the right side, because I don't want minus tan square theta. So it will be 0 equal to tan square theta minus will become positive. 1 plus 2 is 3 will become negative, and 4 tan theta was already here. That's here, and this is a quadratic equation in terms of tan theta. That's what they wanted. Okie dokie, let's go to the next part, where they're saying that hence solve the same equation between 0 and pi should be our solution. So the equation we got was tan square theta plus 4 tan theta minus 3 equal to 0. So we can factor this to get the value of tan theta, but before that we'll have to assume that tan theta is, let's say, p. So the equation becomes p square plus 4p minus 3 equal to 0. And factoring may not help in this, so I will use quadratic formula. Minus b plus minus square root. B square minus 4 is over 2a. So minus 4 plus minus square root 4 square is 16. This is a, this is b, and this is c. This means 1 is a. Okay. So b square is 16 minus 4 times a c. Okay, divide by 2 times a. So minus 4 plus minus, how much is that? 16 times 12 is 12, 28 over 2. So let's get some more space here. Minus 4 plus and square root 28 can be written as 2 square root 7. Yeah, over 2. Since all of them have 2, so we can cancel that. This 2 can cancel with both of them, and we get the answer as, I forgot to write minus here, minus 2 plus minus square root 7. That is the value of p, and that is the value of tan theta, right? So tan theta will give us 2 values now. Tan theta equal to minus 2 minus square root 7, and second one will be minus 2 plus square root 7. Now we want angle between 0 and pi. That means in this quadrant tan is negative, in this quadrant tan is positive. That means we have to take both of them. So tan inverse minus 2 minus square root 7 will definitely be a negative number, which will be the angle, this one, rather not this one, the angle will be this one, but we will write a positive one inside. So let's do that. So when I ignored the negative and I just put tan inverse 2 plus square root 7 in my calculator, I got angle 1.357 almost. Okay, so that is this acute angle, this one. Now I wanted to find this one, and that's why I removed negative, because I knew that it will be second quadrant. So it will be pi minus 1.357, almost 1.783. But when I put this one, it is definitely a positive number, because square root 7 is more than 2, minus 2, and it will give me a positive number. When I straight away put this in my calculator, I'll get the angle I want, and I got 0.573 for this quadrant. In question 6, an expression is given and a and b are constants. If we expand, they say that the coefficient of x and x square are 3 and minus 6 respectively. Find a and b. So the first bracket is simplified, so we don't touch it, but this second one can be expanded because the exponent of the second one is half. Square root is same as half. And if I expand the second one with the help of the formula given in the formula sheet, this is the formula. It can be written as, I'm expanding only this one, okay? It will be 1 plus nx, n is the exponent, which is half, and x is not x in this, x is 4x, so we'll multiply by 4x, and then next one will be n, which is half, then half minus 1 over 2 factorial, 2 factorial is just 2, multiply by x square, and x is, as I said, it is not x, it is 4x, so we'll write 4x square. This is the second bracket, and I'm stopping at square because they are interested in x and x square only. And I will write the already simplified bracket in front. Now, let's focus on the coefficient of x. A will give coefficient of x if it multiplies with this one, which is, let's cancel this one. So a multiplied by 2x will give us 2ax. That is the first one, where coefficient is 2a, but I'm writing x also. Second, bx will give the x when it multiplies with the constant on the other side. There's no other way it can give you x. So bx multiplied by 1 gives you bx. So let's separate x from it. 2a plus b is the coefficient of x, and they said that the coefficient of x in the expansion is 3. This becomes our first equation. Let's move on. If I want x square now, this a will give x square if it multiplies with x square, which is this one. So a multiplies with this half, multiplied by half minus 1 is minus half, divided by 2, multiplied by square of 4x will be 16x square. So we'll simplify it later. This is the x square. What else will give us x square? bx multiplies with just x, this one will give us x square. X multiplied by x is x square. No one else will give us x square. So b multiplies with 2x. So 2bx square will be the sum of the two, and let's take x square common again from this, just like the previous x. So it will be half times minus half is minus 1/4, divided by 2 will be minus 1/8, multiply by 16, this one, plus 2b. There's a also, I forgot to write a, this a will also be written here. Alright, that's the simplified version of this, and finally we can write 8 and 16 will cancel out, actually, 2. So minus 2a plus 2b x square is the term with x square, and 2a minus 2a plus 2b is the coefficient. And they said the coefficient of x square is actually minus 6. So we'll write the equation like that. Minus 2a plus 2b equal to minus 6. So now to eliminate one of them, let's add this previous equation with this. So 2a plus b equal to 3. And since minus 2a and 2a are of opposite signs, they can cancel out. 3b equal to minus 3. And that gives us b equal to minus 3 over 3, that is minus 1. And let's substitute this minus 1 in one of the equations. Let's substitute here in the first one only. We'll get the value of a. 2a and b is now minus 1 equal to 3. 2a equal to 3 plus 1, and if it goes there, 2a equal to 4. A will be 4 divided by 2, and 2 is the answer. Let's move on to the question number 7, and a part of question number 7 is just of 1 mark. They are asking us to differentiate the equation they have given. So this is the equation y equal to ln of ln x. Y equal to ln of ln x. So whenever we want to differentiate something with ln, we first reciprocate what is inside, and then we differentiate what is inside. And when I differentiate this, again the content of ln is x, I'll reciprocate it, and then I'll differentiate what is inside that ln, which is x, and differentiation of x is 1, and that's why the answer will be 1 times 1 times 1 on top, and x ln x at the denominator, and this is what they're asking us to show. Let's see what B part has in store for us. Okay, it is a differential equation they have given, and they're asking us to solve the differential equation, and they've given some information also in addition with the differential equation. X is equal to e when t is 2. So obviously this will be to find c in case we reach at that stage. Okay, so the first thing we should do in a differential equation is to isolate x and dx together and t and dt together. Alright, so I can see x ln x here. So let me bring it to the other side so that I can do cross multiplication. T dx over dt equal to x ln x, and that is going to be negative. Alright, t and dt are already together. That means this dx has to be with this, but the problem is that this dx will become a denominator if I do cross multiplication, and dt is already a denominator. So we will have to cross multiply everything. So let's bring x ln x to the down here. So it will become dx divided by x minus x ln x. Alright, and dt comes and becomes a numerator here, t becomes a denominator here. So now x's are with dx and t's are with dt, and both dx and dt are numerators, and now we will try to differentiate, rather integrate them so that we can get the equation. So let me write minus 1 over x ln x dx equal to 1 over t dt. So the right side is easy, it's straightforward. The integration will be ln t plus c. And the left hand side would be very difficult to integrate since it is a different looking integration, but look at the first part. The differentiation of x ln x was 1 over x ln x. That means the integration of this one would be this. And this fact we can use in our second part, B part of this one. So ln x will be the integration of this one. It will be minus ln x. So in one step we integrated with the help of A part. Now they have given value of x and t to find the value of c. So x is equal to e when t is equal to 2. So minus ln, let's write here. When t is 2, x is e. So ln e equal to ln 2 plus c. Ln and e are inverse of each other. They cancel out and they give us 1. So ln of 1 or log of any number anytime 1 is 0. That becomes 0. So ln 2 plus c, and that gives us c equal to minus ln 2, which we will replace in our equation here. Minus ln of ln x equal to ln t minus ln 2 now. And now let's try to simplify this. Okay, so since all of them are ln, let's combine both sides. Minus ln x was already combined. Let's combine this one also. T over 2. Now since this is negative here, let's give it an exponent of negative, and this is gone, so that we can compare the ln and ln. If both sides are having logs, we can compare the contents of the logs and ignore the logs. So we are left with ln x equal to the power minus 1 rather, t over 2. Now to make this negative a positive, we have to reciprocate both sides. So it will become positive exponent of ln x, and this will be 2 over t. And if we get rid of this x, this ln x will be equal to e to the power 2 over t, and this is the final solution. Question 8. We have been given a definite integral with limits 1 and a, and they're asking us to show that a is equal to this, where exp is e to the power. They could not write it, it would seem to be complicated, so that's why they have written it simplified form. So let's integrate first and substitute a and 1 to get a definite integral. So I will first ignore the limits, and let me write this as 1 over square root x times ln x dx. So I separated the two, and we can use integration by parts now. So LIA TE, that means log will be u, and algebraic one will be v prime. So this is v prime and this is u, and we should know that integration of u v prime is uv minus u prime v. So this question will become uv first. So u is ln x, so I will write ln x, and then v, but we have v prime, 1 over square root 2, 1 over square root x has been taken as v prime. So v prime integration will be v, and that's what we want v for this part. So we'll have to integrate 1 over square root x so that we get v. Now let's change it to x to the power minus half. So 1 over square root x can be written like that. So the integration of this will be x to the power minus half plus 1 divided by minus half plus 1, which will be x to the power positive half over 1 over 2. So 2 becomes numerator. So finally v becomes 2 square root x. This is what we will use at v, because here we wanted v. U is already written, so let me write that 2 square root x in front of this. Okay, now minus u prime will be the differentiation of ln x, which is 1 over x, and then we just got it, 2 square root x dx. So this is square root x, and this x can cancel out. We'll be left with square root x here, and now we are left with 2 square root x ln x minus 2, let's put it out, 1 over square root x dx. And if you know, already we have integrated 1 over square root x here, and we got it 2 square root x, so that becomes so simple after this. So 2 square root x ln x minus 2, and this is the integration of 1 over square root x, so it becomes multiplied by 2 square root x again plus c, and let's apply the limits which we ignored till now, 1 and a. Alright, let's substitute a first. 2 square root a ln a minus 4 square root a plus c minus 2 square root 1 ln 1 minus 4 square root 1 plus c. Plus c and this plus c should cancel first because we get they are constants and there is a negative in between, so we can ignore them. This becomes 2 square root a ln a minus 4 square root a minus ln 1 is 0, so this whole thing becomes 0, so no need to go further in that, but this is there. This will be negative 4 and this negative will make it plus 4, and this is equal to 6. That's what they gave in the question. It is equal to 6. The definite integral we just found out is equal to 6, and we have to convert it to that 6. So do we have something? Yeah, everything has 2, so let's divide the whole equation by 2 so that we get rid of 2. So we'll be left with square root a ln a minus 2 square root a plus 2 equal to 3. This 2 will go to the other side, so, and we can take square root a common in these two. So let's take square root a common, so we're left with ln a minus 2 only, right? Yeah, and this 2 goes to the right side, becomes 3 minus 2, which is 1. In our question they want answer a in terms of exponential, right? A is equal to exponential, that means ln a has to be separated. So let's divide both sides by square root a so that we get 1 over square root a, and they cancel out. Ln a minus 2 equal to 1 over square root a. We are on the right track, looks like. Ln a equal to 1 over square root 2, square root a rather, plus 2. This is minus 2. When it goes to the right side, it becomes plus 2. And finally, we can isolate a. Whenever we remove ln from one side, the other side becomes e to the power 1 over square root a plus 2. This is the exponent of e, and that's what they said. exp 1 over square root a plus 2. Can you see here? We have shown what they wanted. Let's move on to next part, which is verify by calculation that a lies between 9 and 11. So whenever they ask you to confirm a root between a range, and they have given the range 9 to 11, substitute 9 and 11 into this equation by first collecting every item to the left side. So let me do that first. So a minus e to the power 1 over square root x plus 2. This is collected to the left and this is equal to 0, correct? So if I substitute 9, the answer will not be 0. It will be either more than 0 or less than 0, correct? Let me see what I get. So when a is equal to 9, we'll get 9 minus e to the power 1 over square root 9 plus 2. And what I get is minus 1.312. So that means when we substitute 9, we got less than 0, not 0. Similarly, when we substitute 11, let's see what happens. When a is equal to 11, we'll get 11 minus e to the power 1 over square root 11 plus 2. And when I use my calculator, I get positive 1.01. So since 1 is less, 1 is more, that means there will be a number between 9 and 11 that will give us exactly 0. So in such case, what do we write? We write that change in sign indicates presence of a root means solution, between a equal to 9 and a equal to 11. That's what it means, and we have verified it. Okay, what about the next one? Use the iterative formula based on the equation in part A. So this is part A solution, and we'll use this as iterative formula. And why iterative formula? Because both sides have A. Let me rewrite the formula again. A is equal to e to the power 1 over square root a plus 2. This was the equation. The one on the left, which is isolated, we write this as n plus 1. The one on the right side is written as n. So, which means that this a will be the next a if I substitute something here. So, because the answer is confirmed to be between 9 and 10, 9 and 11. So, I will take the number in between, which is 10. I will start with 10, and that becomes our a1. That means a2, which is n plus 2, right? a2 will be e to the power 1 over square root 10 plus 2. Let me use my calculator to find this. And by the time I evaluate this, I would request you to subscribe to my channel, share and like this video with your friends, and let them also have benefit of understanding these detailed solutions. I try to make solutions also teach you how to answer the future questions. So please like and share it and motivate me to make more videos. Alright, when I use my calculator, I got 10.1372. Okay, they said we have to write each iteration to 4 decimal places. And that's what I've written, 4 decimal places. But our answer will be in 2 decimal places, that will go there. So let's go to the next one. A3 will be e to the power 1 over, and whatever we got A2, that becomes your A here. So 10.1372. Okay, that's it, plus 2 also. And I got now 10.1157. Okay, next A4. You might be wondering, where will I stop? Okay, when I will stop, I will let you know why did I stop. So I'm writing 10.1157 plus 2. I get 10.1179. And now I will stop. Why? Because they said the answer should be in 2 decimal places. So round off each step with 2 decimal places. So it will be 10.13 here, 10.12 here because of this 5, 10.12 here. When 2 decimal places give you 2 consecutive numbers, give you same round off, 10.12, stop there. So that means our final answer is A is equal to 10.12, correct to 2 decimal places. Let's move on to the next question, which is based on vectors. Question number 9 has given us the equations of 2 lines, and we have to show that they are perpendicular. So the direction of lines is decided by the vector part, and the vector part of this one is this, the first line, the second line is this. So if they are perpendicular, the dot product of these two directions will be 0. So what I mean is this: 4i minus j plus 3k dot minus I plus 2j plus 2k should be equal to 0. And let's see if it is actually 0. So whenever we find the dot product, we multiply the coefficients of I with I, which is minus 4 in this case, j with j, minus 2, and 3 and 2, k and k, plus 6. Is this equal to 0? Yes. Minus 6 plus 6 is equal to 0. Yes, the lines are perpendicular. Alright, what about the B part? B part says show that L and M intersect and state the position vector of the point of intersection. So we'll just find the point of intersection first and we'll convert that point into position vector. So there's not big difference. I will let you know when we reach there. So the first equation is L. Let me write it here. And second equation is M. The equations of the two are, let me copy them one by one. This one is R equal to 3i plus 2j plus 5k plus S 4i minus j plus 3k. Okay, the line M is R equal to I minus j minus 2k plus T minus I plus 2j plus 2k. Now, if this is the line L, this is line M, this is the point of intersection, and this point lies on both the lines. It means that whatever is the x coordinate of this, let's call it x, y, and z. These are the coordinates of this point of intersection. In this case, x will be in I direction, which will be 3i plus 4is. And we don't write I are unit vectors. So we can write this as 3 plus 4s. This 3 plus 4 times s. Similarly, y will be 2 minus 1s, 2 minus s. And z coordinate will be 5 plus 3s. Similarly, because this point lies on line M as well, we will make it equal to 1 minus t. Minus 1 plus 2t. And 2 minus 2 plus 2t. So, since we have two variables, two equations are enough to find the value of s and t. However, any combination of s and t will give you solution. It will be a real solution if these two solutions verify with the third equation. Then only we will say yes, they intersect. So, let's find the value of s and t with the first two equations. So, 3 plus 4s equal to 1 minus t. Let me rearrange it. It will become 4s plus t equal to 1 minus 3, which is minus 2. The second one will be minus s minus 2t equal to minus 1 minus 2. So I have rearranged so that I get s and t on one side. So let me multiply the second equation by 4 so that I can eliminate s as compared to the first equation. So it will become minus 4s minus 8s 8t equal to this minus 3 times 4 minus 12. And the first equation was 4s plus t equal to minus 2. And we can cancel this. This becomes minus 7t. This becomes minus 14. So that gives us t equal to minus 14 over minus 7, which is plus 2. We got the value of 2. Now, we'll find the value of s and we can choose anyone. Let me choose this one. 4s and we have t now, 2 equal to minus 2. This 2 goes to the right, becomes 4s equal to minus 2, which is minus 4. So s becomes minus 4 over 4 minus 1. We got the values of t and s based on first two equations, but as I told you, only third equation will confirm whether these two lines are intersecting or not. So let me take this one, 5 plus 3s, 5 plus 3 and s is minus 1 according to the solution, equal to minus 2 plus 2t, t is 2. So 5 minus 3 equal to minus 2 plus 4, this is 2 and this is also 2, yes, that's correct. So whenever third line verifies the first two solution from the first two equation, we say that yes, the two lines are intersecting. We have shown this also. But this is not enough. They are asking us to write the position vector of the point of intersection. So since we have everything ready with us, we can take either t or s to get the coordinates x, y and z, and let me do that. Let me use this one. So t is equal to 2. I will put it here. It will become 1 minus 2. The x coordinate will be minus 1. Here it will be minus 1 plus 2 times 2. 4 minus 1 is 3. And this will give us minus 2 plus 2 times 2. That becomes 4 minus 2 equal to 2. Minus 1, 3, 2. So I will write the final answer here. The position vector of the point of intersection is minus I plus 3j plus 2k. And the reason behind this is that if these are the two lines and we got the point of intersection minus 1, 3, 2, somewhere we'll have origin, right? Origin is here. So whenever we have a vector from origin to a point is called position vector. And whatever is the coordinate, what are the coordinates of head become the position vector, and that's why I wrote this as position vector, because with comparison to 0, 0, 0, these are the position vectors and they are expressed like this. Let's get to the next part of the same question, which is this. Show that the length of the perpendicular from origin to the line M is 1 over 3 square root 5, and this will need some work. And I'm ready with it now. So this was the parametric form of the vector equations of the line M. They're saying line M, right? So we have to imagine this is line M. Somewhere is origin. I'm not looking at line L anymore, and there is a perpendicular from origin to this point. This is origin, whose coordinates are 0, 0, 0. This is the foot of the perpendicular on the line M. Let's call it the coordinates as ABC, right? Since this point, let's call this point as P, lies on the line M, it will satisfy these three parametric equations. That means we can write these as 1 minus t, comma, minus 1 plus 2t, comma, minus 2 plus 2t. Right? And since this is the head of the position vector from O to P, OP, right? This becomes the position vector 1 plus Ti plus minus 1 plus 2tj plus minus 2 plus 2tk is the position vector OP. Alright? And we know that the vector of this line M is this minus 1 minus I minus I plus 2j plus 2k. Since they are perpendicular, again their dot product will be 0. And that's what I'm going to do now. So the dot product of 1 plus, actually it is 1 minus. This is minus, right? This is minus. 1 minus t dot, this is minus 1, so minus 1 plus minus 1 plus 2t dot 2 here plus minus 2 plus 2t dot 2 here equal to 0. So let's open the brackets. Minus 1 plus t minus 2 plus 4t minus 2 times 2 4 and plus 4t equal to 0. So let's collect t's. T plus 4 5, 5 plus 4 9t, minus 1 minus 2 is minus 3 and minus 4 minus 7 equals 0. 9t equal to 7. So t comes out to be 7 over 9. And now we have the t, we can use parametric equation to find the coordinates ABC. So let's plug them one by one here for simplicity. So 1 minus t, t is 7 over 9. 1 minus 7 over 9 will be 2 over 9. Alright, minus 1 plus 2 times 7 over 9 is 14 over 9. That will be 5 over 9. Okay, minus 2 plus 14 over 9 again, so minus 18, minus 4 over 9. So the coordinate of ABC are 2 9th, 5 9th and minus 4 9th. And this is the vector also, the position vector from origin. So we'll just find the magnitude of this vector. The vector, we can write it as OP equal to 2 over 9 I plus 5 over 9 j minus 4 over 9 k. So let's write the magnitude of this will be square root 2 9 square plus 5 9 square plus minus 4 over 9 square, which will be 4 over 81 plus 25 over 81 plus 16 over 81. So that becomes how much? 29 plus 16, 45 over 81. We can simplify this by dividing by 9, so it becomes 5 over 9, square root 5 over 9. So square root 5 remains square root 5, but 9 has a square root over 3. And in what format they want us to express it? Let's see. 1 over 3 square root 5, which is perfect. Which can write this as 1 over 3 square root 5 units. We've shown it. In question number 10, they have given a complex number 1 plus 2i, which is u, and it is a root of this equation equal to 0, this expression polynomial equal to 0, and they're asking us to find the value of a and b. So whenever we have a root available to us, just substitute that into the polynomial and make it equal to 0. That's why it is called root, because it makes the polynomial equal to 0. And that's what I'm going to do here. So 2, and in place of x we'll plug in u, which is 1 plus 2i plus a and plus 4 plus b, and it should be equal to 0 because we have substituted the root. Alright, let's open all the brackets. 1 plus 2i cube. We have identity. If you're not aware, just learn this one, a plus b cube. Yeah, that's the one format here. which will be a cube plus b cube plus 3a square b plus 3ab square. If you're not aware of this or you can't remember this, then you'll have to do it individually. 1 plus 2i multiplied by 1 plus 2i multiplied by 1 plus 2i, and you'll get what I'm directly writing here. So first one is a cube. That means 1 cube is 1. Then we have b cube. B cube will be 2 cube is 8. And I cube. Then 3a square. 3a square. 1 square is 1, so I'm not writing it. And b is 2i. Then 3a is 1. Again, I'm not writing it. But 2i is squared. That's it. That's the cube. Let's open the other bracket also. 1 plus 2i square will be a square, which is 1 square, plus b square, 2i square, plus 2ab. 2 times 1 times 2i. That's the expansion of a plus b square. Alright, remaining is this. 4 times 1 is 4. 4 plus 2i is 8i plus b equal to 0. And we have to open the brackets further now. 2 times 1 is 2 plus 16 I square I. So I'm breaking this I cube into two parts so that I can substitute the value of I square. We know that I square is minus 1, so that's what I want to use here. Then 3 times 2 is 6. 6 times 2 is 12 plus 12i. Now this 2i is being squared, so it will become 4i squared inside times 3 is 12, and that times 2 is 24 I square. Okay, a times 1 will be a. This will be 4i square again, so plus 4ai square if I multiply with a. Then 2 times 2 is 4, and ai will be the expansion of this one. Then plus 4 plus 8i plus b are already there. Now this 0, we can write this as 0 plus 0i because that is not going to make any difference. That means I can equate the real part with this 0 and imaginary part with this 0, and that will give us the answer. For that I have to separate real and imaginary parts. So 2 I have here, and this has imaginary part still there. This has imaginary part. Okay, this one is minus 24 now because I square is minus 1. Okay, a is real part. What else? Yes, this is also minus 4a because I square is minus 1. Alright, this is imaginary. This is 4 plus 4 and b. That's the real part. Now, imaginary parts I will write without I. This will be minus 16, then 12, this one, and then we have taken this one. This is done, this is done, this is remaining, plus 4a, then plus 8i, okay, 8, and done. And I outside equal to 0, 0 plus 0i. Now I can equate the real part with 0, and that will give me an equation. So let me do that. 2 minus 24 is minus 22, minus 22 minus 18. A minus 4a is minus 3a plus b equal to 0. This is one equation. Second equation, minus 16 plus 12 is minus 4 plus 8 is 4 plus 4a. This is also equal to 0, and this can straight away give us the answer. Minus 4a is minus 4 over 4 minus 1. We got the value of a. What about b? Minus 18 minus 3, and now we know the value of a is minus 1 plus b equal to 0. Minus 18 plus 3 is minus 15 plus b equal to 0, and b becomes 15. That's the value of a and b. What is the second part? Let's talk about it now. State a second complex root of the equation. So That is the easiest one we can have, and this one is worth 1 mark only. 1 plus 2i is one of the roots, so the conjugate of it, 1 minus 2i, will be the second root. That's simple. Next is find the real factor of polynomial x. Alright, so what do we do? First we'll find what is the multiplication of the two factors given by the two roots. So 1 plus 2i was one root. This can be written as factor like this: x minus 1 plus 2i. Second factor was 1 minus 2i, we just wrote it, conjugate of the first. It will be written as x minus 1 minus 2i, and multiply these two. They will give us the combined factor by the two. So what I'm going to do now, I'm multiplying them. X minus 1 plus 2i multiplied by x minus 1 minus 2i. Now let's open the brackets first. It becomes x minus 1 minus 2i. This becomes x minus 1 plus 2i. And we know that identity again, a minus b multiplied by a plus b is equal to a square minus b square. And that's what we'll do. We'll consider x minus 1, whole of it, as a, and 2i as b. So look, it is a minus b and a plus b format, and it will be a square minus b square. That means the combination of the two will be x minus 1 square minus 2i square, which will be x minus 1 square will be x square plus 1 minus 2x, and this will be minus 4i square. And we know I square is minus 1, so it becomes what? It becomes plus 4. So it becomes x square minus 2x plus 5. This combined factor by the two of these factors give us x square minus 2x plus 5. Because I square is minus 1, this becomes plus 4 plus 4 plus 1 plus 5. Alright, now let me copy the original polynomial. This is the one, and we know the values of a and b, so we substitute the values of a and b as well. So let me write it down there so that I don't make any mistakes. Alright, so I have to divide this polynomial by this factor. So it is 2x cube, and a was minus 1 minus x square plus 4x, and b was 15. We have to divide this by x square minus 2x plus 5. Let me do it first. I hope you understand how to divide. Okay, so we got 2x plus 3 as the third real factor or root is 2x plus 3. Okay, let's move on to this next part, which is about arcane diagram. On a sketch of an arcane diagram, shade the region whose points represent complex number z such that this. Okay, so first condition is z minus u is less than equal to square root 5. So whenever we have this, so let's first of all write z minus u will be same as z minus 1 plus 2i, because that is u, right? That was the given in part 1. So we'll see where is 1 plus 2i. This is 1, a real part is 1, and 2i is here. So this point of work is 1 plus 2i. Our z, modulus of z from u will start from here, and since they have given that it is less than equal to square root 5, that means we will draw a circle whose radius is square root 5. Why? Let me give you the reason later. Let me draw it first. Okay. Somewhere here. Okay. Why? Why this? That I have drawn a circle here and that to a thick circle. The reason is that any point inside this circle, the distance from that point to this this is u, okay, this point where the center is, will be less than square root 5 because the radius of this circle is square root 5. So every point is less than square root 5 units distant away from this center. That's why I do this circle and I have fulfilled the first condition, but I'm not shading the whole circle from inside because second condition has also to be met, and then we will write the combination of the two. Second one is z is less than, argument of z is less than equal to 1/4 of pi. So can I write this z as z minus 0? Because whenever we have just z, we should write z minus and some number, but because there is nothing after that, we'll take it to 0. That means from the origin there will be a line. This is a half line and we'll get a line which is 45 degrees pi by 4 from origin. This is what we got. So we already knew that the inside of the circle is shaded. Now we have to shade less than pi by 4 and this whole area will be shaded now. Even under this line is also shaded. Why? Because minus some argument in negative direction is also less than pi by 4. That's why we are shading the lower part also under half line. Alright, let's see what the next part is asking us to do, which is find the imaginary z for the shaded area. Okay, so imaginary is this axis, the vertical axis is imaginary, this is real part. Alright, so this will be the point here. Basically they're asking us what is this coordinate. This is the least value for imaginary z. This will be the least value in negative zone. Let's call it a. So a is a level which is, we know this is 2, and we know the distance between the center and the circumference is square root 5. So it will be 2 minus square root 5. This will be the value of a. And they're saying give it in exact form, right? Exact form. So 2 minus square root 5 will be the value of a.